Hey everyone, welcome to The Explainer. So you've heard about Go, right? Maybe you're a little curious? Well, you've come to the right place. Today, we're not just going to look at another programming language. We're diving into a completely different philosophy for building software. We're going to unpack what makes it so unique and what it really takes to think in Go.
Let's just jump right in with a quote that is, it's basically the soul of Go. This isn't just some clever little phrase. It is the core principle behind Go's entire approach to concurrency. Keep this one in your back pocket because we're going to see exactly how it plays out.
Okay, so to really get Go, you've got to understand its origin story. This wasn't a language cooked up in some academic lab. Nope. It was forged in the fires of Google to solve massive real-world engineering headaches. We're talking huge code bases with thousands of developers, all trying not to step on each other's toes. And this really gets to the core trade-off Go makes. It's all about valuing readability for the next person who has to look at your code, way more than your own convenience while you're writing it. The language also chooses long-term stability over just piling on more and more features. If you try to write Go the same way you write Python or Java, you're just going to be fighting the language the whole time. You have to embrace the mindset.
And what's so interesting here is how these ideas almost feel, a little rebellious today, right? Simplicity is king. You favor simple composition over these complex, tangled webs of inheritance. Concurrency isn't an afterthought. It's a first-class citizen. And maybe most importantly, everything is explicit. No hidden magic. While other languages are in an arms race to add features, Go just stays ruthlessly simple.
And this number, it just perfectly illustrates that commitment. 25 keywords. That is it. For comparison, a language like Java has more than 50. Now, this isn't about being primitive. It's a very deliberate design choice. The philosophy is, if a feature makes the code harder to read, even if it makes it a tiny bit easier to write, Go just says no.
All right, so that's the philosophy. But how does it actually feel to write the code? Let's get into the syntax, and we'll start with the parts that new developers often find, well, let's just say a little uncomfortable at first.
Get ready to type this. A lot. A lot. This one simple block of code can end up being a huge percentage of your entire code base. You're going to write it thousands of times. And at first, believe me, it feels incredibly repetitive and kind of clunky.
And yeah, this is the first question everyone asks. Why doesn't Go just use the try-catch exception handling that pretty much every other major language has? The answer tells you everything you need to know about Go's obsession with being explicit.
So here's the deal, the really crucial point. In Go, there's no invisible exception that can just bubble up out of nowhere and crash your whole program. Errors are just values returned from functions like anything else. This means you, the developer, see every single possible failure path right there in the code, and you're forced to decide what to do about it then and there. Okay, let's talk about the next big trap for newcomers, slices. They kind of look and feel like dynamic arrays, but they are not. A slice is really just a small header that points to a bigger hidden array underneath. And understanding the difference between its length, that's the number of elements you're currently using, and its capacity, the total size of that hidden array, is absolutely critical. And this is where things get really dangerous. Imagine you slice a massive 50 megabyte array just to keep a tiny 10-byte piece of it. Well, that tiny slice is still holding a reference to the entire original array. This means the garbage collector can never clean up that 50 megabyte blob. Your tiny little slice is secretly holding a huge chunk of memory hostage.
Okay, we've talked about the uncomfortable parts, the traps. Now for the payoff. Let's get to the feature that makes Go famous. It's incredibly simple, incredibly powerful concurrency model. This is really where the language just sings.
So, when you're writing concurrent code in Go, you're not actually using OS threads directly. Nope. You're using something called Go routines. And they are a completely different beast. They are unbelievably lightweight, managed entirely by the Go runtime, not the operating system. And what that means is you can spin up tens, even hundreds of thousands of them, without your system even breaking a sweat.
So you've got maybe hundreds of thousands of these Go routines running around. How on earth do they talk to each other without causing total chaos? Well, this brings us right back to that quote from the beginning. Instead of sharing memory and then using locks to protect it, you share memory by communicating. You pass data through these things called channels, which are basically like typed thread-safe pipes. It's a way to safely hand off ownership of data from one Go routine to another, which prevents a whole class of bugs by design.
Now here's a super important tip for anyone new to Go. Don't go crazy and try to use channels for absolutely everything. They are for communication, for orchestrating work. If all you need to do is protect a simple piece of shared data, like a counter or a cache, a good old-fashioned mutex is often way simpler and honestly much, much faster.
All right, let's bring it all home. How does this stuff actually come together to help us build real, solid, production-ready systems that are easy to deploy and even easier to maintain? You want to know Go's secret weapon? I'd argue it's this, the race detector. This isn't just some linter that guesses about problems. It actually finds data races while your code is running. You just add one little flag, race, when you run your tests, and it will pinpoint these incredibly nasty concurrency bugs that are almost impossible to find manually. And here's the thing, you can trust it, 100%. There are no false positives. If this tool flags something, you have a legitimate, dangerous bug in your code. You should absolutely run this in your CI pipeline, always. It's a total lifesaver.
I really can't overstate how huge this next feature is. Go compiles everything, your code, all its dependencies, the whole shebang, into one single file. That means your deployments can be as simple as copying one file. And in a world of containers like Docker, it means you can build these unbelievably tiny images, often just 10 or 20 megabytes. It's a massive win.
Think about modern apps, right? You've got all these services talking to each other. You need a way to keep track of a single request as it flows through the system. The context package is Go's brilliant answer to that. It's how you build resilient systems. So if a user cancels an HTTP request, the context can instantly signal a downstream database query to just stop, freeing up resources immediately.
Okay, so we've covered a lot. Here's your cheat sheet, your takeaway checklist. If you're building a real system in Go, these aren't just, suggestions. These are the non-negotiable best practices. Follow these rules, and you are going to save yourself from so many headaches down the line.
And this all leads us to the central question, the big debate about Go. Its stubborn refusal to add more complex features is what makes it both frustrating to newcomers and also what makes it so powerful for huge teams. It trades a little bit of convenience for the writer for massive gains in readability and stability for everyone else. So, is that a bug, or is it the language's greatest feature? That's what you have to decide.